Let's briefly look at circles. Okay, what I've got here is the cheapest possible paper plates I can find. You can sort of run them over the edge to make them a little flatter. You don't have to use those. I just happen to use those for my manipulative. These are a circle. Now, first thing about a circle is we need to know what the center is. Well, by folding, if I fold this in half, and just notice I'm just creasing in the middle here, then I'm going to repeat that process in the different directions. And you notice where those two things cross, notice when I did the fold, I created two diameters, half the circle. So those are two diameters. All diameters intersect in the center. So two quick folds means I've identified the center of the circle. Having a manipulative like this for the kids to draw on and work on can often be very valuable. Here, for instance, I took a plate after finding the center. I drew a central angle, an inscribed angle that matches that one, and a diameter. And I've got them labeled. By physically doing this and physically writing themselves, as opposed to just seeing a digital image or a worksheet, their chances of remembering increase. Notice in here, I can actually talk about the central angle and the inscribed angle, and notice the inscribed angle is always smaller. The fact that it's half would be more work, and I could actually do that with paper folding too. But more importantly is I can see immediately there's probably some connection there, and it's not going to be direct. This has to be smaller. And again, the diameter I did in a different color. In addition, I'm going to look at another question concerning circles. It's kind of interesting. Here is another circle, and I have drawn a 1 radian. Now, out to the edge here, I'm going to fold this point in to touch the center. And my question is, what central angle have I made when I did this process? And the central angle I made is 120 degrees, or more accurately, a third of the circle. I'm going to draw the 2 radii here. Okay, question is, can I prove that? Well, okay, let's look at this fold. This is the chord I made, and okay, I could have put chords on here. That chord's going to make a right angle here. So let's assume our radius is 2. That means that this is 2. When I did this fold, I cut the radius in half, so this length is 1. So I have a right triangle with a hypotenuse of 2, and this leg is 1. If I do the Pythagorean theorem, I find this is the square root of 3, which means I've got a 30, 60, 90 right triangle. So this is 60 degrees, and this is 60 degrees. So this fold found me a third of the 360 degrees. If I folded in all 3 of them, I'd get an equilateral triangle.